Hey there, universe nerds. Imagine a star so massive, so powerful, that when it dies, it doesn't just fade quietly into the night. Instead, it explodes with the brilliance of 100 billion suns, outshining entire galaxies for weeks. That's a supernova, one of the most violent and important events in the cosmos. These explosions are not just fireworks, they're the reason you, me, and everything we know exists. Today, we're going to explore how supernovae happen, why they matter, and what they reveal about the life cycle of the universe. So, what is a supernova? In simple terms, it's the death of a star, but not every star. Our sun, for example, is too small. It will end as a white dwarf. Supernovae happen when massive stars, at least 8 times the mass of the Sun, reach the end of their lives. After burning through their nuclear fuel, they can no longer resist gravity. Their cores collapse, and in a fraction of a second, the outer layers blast outward in a titanic explosion. The energy released in that instant is greater than what our sun will produce in its entire lifetime. There are 2 main types of supernovae. Type 2 supernovae come from the collapse of massive stars. Type 1a supernovae, on the other hand, happen when a white dwarf in a binary system steals too much material from its companion. Once it reaches a critical mass, it undergoes a runaway nuclear reaction and detonates. Both types are powerful, but they leave different fingerprints in the sky, helping astronomers identify them. Supernovae don't just destroy, they create. The intense heat and pressure inside the explosion forge heavy elements like gold, silver, and uranium. These elements are blasted into space, mixing with gas clouds that will form new stars and planets. That means every atom of calcium in your bones, every atom of iron in your blood, was born in a star and released by a supernova. We are literally made of stardust recycled from the deaths of ancient suns. Supernovae are also cosmic beacons. Type 1a supernovae shine with nearly uniform brightness, making them standard candles for measuring distances across the universe. In fact, it was by studying distant supernovae that astronomers discovered the accelerating expansion of the universe and the existence of dark energy. These explosions are not only spectacular, they are tools for unraveling the deepest mysteries of cosmology. But they're dangerous too. If a supernova went off within about 30 light-years of Earth, its radiation could damage our ozone layer and disrupt life. Fortunately, no nearby stars massive enough to explode are in range. The closest candidate is Betelgeuse, a red supergiant about 640 light-years away. It could explode anytime in the next 100,000 years, tomorrow or long after humanity is gone. When it does, it will shine brighter than the full moon, visible even in daylight, but harmless to Earth. Astronomers study supernovae with telescopes across the spectrum: optical, radio, X-ray, and gamma ray. Remnants like the Crab Nebula or Cassiopeia A reveal the aftermath, glowing shells of gas still expanding centuries after the blast. Inside, neutron stars or black holes often remain, the compact cores left behind by the collapse. Each remnant is a cosmic laboratory, teaching us about physics under conditions no Earth experiment can replicate. Supernovae also connect to the next great cosmic events. When 2 massive stars both explode and leave behind neutron stars, they can later merge, creating even bigger explosions called kilonovae. These collisions release gravitational waves and create more heavy elements. In this way, the death of stars sets the stage for the birth of new ones, continuing the endless cycle of creation and destruction in the cosmos. So,
What really happens when a star explodes? It collapses, ignites, and erupts in light that can be seen across the universe. It seeds the cosmos with elements, reshapes galaxies, and leaves behind exotic remnants. Supernovae are both endings and beginnings, the cosmic fireworks that ensure the universe keeps evolving. Next time you look at the stars, remember, some of them are destined to die spectacularly. And when they do, they'll leave behind the ingredients for new worlds and maybe even new life.